we are on 14.4 and we're looking at receptors. And we have talked already about the sodium ion channels and the sodium potassium pump in the membrane of a nerve cell. So we talked about how it's the influx of sodium ions into the cell that then, if it's big enough, basically leads to the action potential. And one of the things that we didn't really mention was that those sodium ion channels that are in the membrane are called stretch mediated. In other words, they're just controlled by stretch. But we did sort of allude to that when we talked about if you pressed on the neuron membrane, which is inside here, then that is going to deform the receptors on that membrane and allow the sodium ions through. So that's our simple example, and this Pacinian corpuscle basically looks like this. You've got your neuron in the middle, and that's where your stretch-mediated sodium ion channels are. And then around it, it's almost like a bit of an onion skin. It's layers and layers and layers. So when you press on that, you are actually pressing on the sodium ion channels, but you're pressing from the outside.
By pressing, do you mean like the impulse pressing onto it?
No, like physically pressing, like proper mechanical pressure.
So you mean they're on the skin surface, so when you touch it,
Yeah.
it's the impulse?
Yeah, so like if you imagine you've got this on your skin, and here you've got a sodium ion channel there, and basically if you press there on your skin, that's going to deform that channel and open it, and more sodium ions are going to run in them. Which then, if it's big enough, if the generated potential reaches threshold, then we get the whole shebang, which is an action potential. And the action potentials are always the same size. How we interpret pain as more or less is by the frequency of action potentials along that neuron, not about the size of your action potential. We do come back to that a little bit later on. So basically, all we're saying is that the sodium receptors, the sodium channels that are on that membrane are called stretch mediated, and they're hidden inside this onion-like structure that's got all these different layers here.